Alright guys, I made a lot of progress with the Banshee VGT controller controlling the hydraulically controlled variable nozzle that's found on the Ford 6.0 and the Duramaxes. So what's unique about these turbos, it's a variable nozzle, so you have a few nozzles wrapped around a circle, and as they pivot, they change angle of attack. That basically compresses the exhaust gas, high pressure to low pressure, increases velocity, goes across the turbine and accelerates it. What's unique about these compared to the whole sets is, as you can see how it changes. The whole set VGT doesn't really do that. So a whole set VGT has a sliding wall that protrudes out, so the actual angle of attack doesn't change. It just changes the amount of distance, the geometry where it can actually get channeled in. So in my opinion, which I could be wrong, but I believe any VNT will outperform a whole set VGT when it comes to just spooling. Now the whole set VGT is hands down better for an exhaust brake. On my 2007 5.9, I was able to make 63 pounds of exhaust pressure all the way down to 20 miles an hour. I doubt these will be able to do the same thing. Alright, so this one here is the Ford Powerstroke. This is the Ford Powerstroke exhaust housing. As you can see, it has a V-band. These two are actually an Isuzu. Came off of like a box truck, a big box truck with an Isuzu in it. I can't remember the name, but I'm pretty sure if you look at the part number, you can probably figure it out. Now to make the Banshee controller control these, you have to have the Duramax position sensor. So these might be in a few other ones, but you can get these on eBay. They say they're for the Duramax for about 20 bucks. So all the VA series, unless it's equipped with this already, has this Allen bolt. So in here is a shaft, and as this actuator moves the vane back and forth, that shaft has a hump in it, and that hump, as it moves, depresses this sensor. So this Ford 6.0 turbo, I have this sensor right here. It's the same thing. So to make this work, you have to calibrate. Well, once you install it, you have to calibrate the controller, same thing you'd have to do with the Duramax, to how this is positioned. So you might have yours a little tighter or a little looser than I do, and that's going to change how this nipple's pressed on its position, and it's going to vary that voltage. So you want it to get as precise as humanly possible. So I'll go through how the Banshee controller calibrates this. Oh man, I didn't bring my arm. Alright, so what I've been doing is I've been using shop air. I'm a benchtop tester, which essentially is the same thing as my Banshee controllers, just in a slightly different configuration. I have my Banshee software updated, as well as the firmware for the Banshee controller. So it's pretty spot on now. There's no load on this. So on the truck, you know, you have exhaust pressure, you have the friction of the unison ring, you have the friction of the back plate that holds all the nozzles. So there's a lot more force being exerted on it. So on here you're going to see little oscillations, which isn't a big deal. But like I said, when you actually install it on the truck, it won't do that. Alright, so this is the Banshee software if you guys aren't familiar with it. Currently connected. So select your turbo. The Banshee controller can control quite a few turbos, so you just go to turbo selection. Now right now I only have 4 turbos in here, but I can control probably about 20 or 30 different ones. Alright, to calibrate it, you're just going to click on calibrate. Now, like I was saying, take this back off real quick. How you have the voltage varying. So right here, the current voltage, that current voltage is what the sensor is currently producing. And then your low voltage is wide open, so when it's turned all the way over here. And then your high voltage is when the turbo's already closed, and that would be your exhaust brake if the turbo can support it. Alright, so I'm going to put this unison ring back on. All you do is click calibrate. Don't worry about the text box, the data's not right. I still have to update that. So all you're going to do is click OK. Now it's going to move this wide open. It's going to come back. Now it's closed. So now the voltage has changed. Alright, so the voltage has changed. So now my low pressure, well, my low voltage is 1 volt, my high voltage is 4 volts, and there's 2.9 is my voltage span. So that's from your high to low voltage. And you need this, so when I go to my gauges, I'm going to take the unison ring off. So now I'm commanding it to 0, and my feedback is 0. So as I rotate this knob, now you can see my position is changing. So when it comes to the logic on how to control it, there's two types of logic. You have a static ratio and you have the variable, which is a dynamic ratio. So the static ratio, which is right here, what you're saying is you want a 1.3 to 1. So for every 1 pound of boost pressure, you're going to have 1.3 pounds of exhaust pressure. So if you have 10 pounds of boost, you're going to have 13 pounds of exhaust pressure. And this is going to go from being from idle, well, as soon as you get off idle, all the way to wide open. As you come back to idle, the controller is going to try to regulate the turbo to maintain that 1.3 to 1. Now your starting position, what that means, so if you look at the feedback, you got 0, which would be your exhaust brake, and you have 100%, which is wide open. Out of that whole 100% range, the controller is going to move you down to 25. So that means if you're not exhaust braking, you're just driving around town, whenever you come back to an idle, as tight as it's ever going to be is 25%. And then it's going to start from there and open itself up as you build pressure. And as you lose pressure, it's going to come back down and it's going to stop at 25%. So that's what that starting position means. If you change the starting position higher or lower, whatever that starting position is, that's the starting position of the turbo every time you take off. Now, when you go to an exhaust brake, it's going to go the opposite direction and it's going to tighten down. So go over the other features real quick. You got your variable table. So the variable ratio is the same thing except you have 10 slots. So 0 psi, which is your idle, the controller is going to try to regulate 2.5 to 1, but it's never going to go lower than that 25, so you'll never actually see that idling. But the benefit is in the second block, so I have 2 psi here, so it's going to have a 2.5 to 1, and then it's going to drop down to 1.8 to 1 when I make 2 pounds, and it's a linear straight line distance between the two. And all that's going to do is it's just going to hold 25 just for a little bit longer than it should, and it's just going to help build a little bit of pressure, kind of like potential energy, to get that turbine going. And then it's the same thing. So as you build more pressure, you can see my target ratio is actually dropping down. So as you build pressure, you can make the turbo more efficient. And then when you slow back down, you build a little bit more exhaust pressure, and that exhaust pressure is what's going to help get the turbo going when you actually give it gas. Exhaust brake control, it's pretty simple. The exhaust brake has 3 triggers essentially. You have a toggle switch which activates the feature. You'll have another line input that's designed for idle validation, or if you have a plug-in on ECU, you could tap into that basically says, hey, your foot's off the accelerator. But the whole goal is to get voltage on that wire whenever your foot's off the gas. And that basically makes the exhaust brake autonomous. You want to brake, you flip the switch, take your foot off the gas, the brake kicks in, you give it gas, the brake turns off, just like it does on a factory truck. The third trigger is the engine RPM. So you normally want this about 200 RPMs higher than your idle RPM. So if you idle at 750, you want 950 in here. And all that's saying is your foot's off the gas, the toggle switch is on, your exhaust braking, and then you slow down and the engine drops below 950. When it drops below 950, it turns off, and then you're idling. You give it gas, you take off, take your foot off the gas. As long as your RPMs are above 950, it turns on and off like it should. If you don't want to use this, you can bypass the engine RPMs. However, when you come down to an idle, the brake's going to kick in and it can bog down your motor. So this is a voltage threshold for the input. So if you use a toggle switch, you know you should have 12 volts. If you're using like your ECU might push 3, 4, 5 volts. They're all different. And this is just basically telemetry of that voltage, so you can actually see what it is in real time. So the pressure regulator is actually pretty cool. What this allows you to do is if you have like a 6.5 or another motor where you want an exhaust brake, but you know the heads really can't take it, and you don't want to blow a head gasket, well, here you enable this and you basically put 25. So if you put 25 here, when the exhaust brake kicks in, it's actually going to regulate your exhaust pressure to 25. If you want 30, put 30, 40, 50, 60. You put really any number you want in there, but if you go high, if you can only make 50 pounds and you put 60 in there, you're only going to see 50 because that's as much the turbo and the engine can make. Like I said, on my 2007 5.9 with the whole set VGT, I was able to make 63 pounds. Alright, so the cold start and wet stack prevention. So the cold start feature, with these turbos, you're really not going to get all three benefits. You'll get two of them. The first one you're not going to get because it's hydraulic. If it's electric, you can use it, and basically the concept behind it is when the engine's off, it's going to close the exhaust housing, and that's going to be essentially your brake. But what's going to happen is when you're cranking on the motor, it's going to help build all that exhaust pressure, and that exhaust pressure is just going to help heat the cylinder to get it to crank over. Once it gets 150 RPMs, it goes right to that 25 or 30, whatever you set at your starting position. The cold start exhaust pressure, what that does is once the engine's running, it's going to start closing down the exhaust housing. So on my truck, I have it set to 10 pounds. So it'll sit there and idle with 10 pounds of exhaust pressure. And you can put 20, 30, 40, 50, you can put whatever you want. But the higher the pressure, the harder it's going to be on the motor. I think 5, 10 pounds, that's a good amount. And all you're doing is putting a little bit of load on the motor, and it actually helps heat it up faster. The wet stack prevention, all that does is whatever your PSI you have set here is when, if you're, let's say you're on an oil farm, you're up in Alaska, Canada, you know, somewhere where it's really cold, all you're going to do is after 10, 15, 20 minutes, whatever you program it, is when the exhaust brake's on and you're idling, it's going to come back and start regulating that exhaust pressure to whatever that's set to. So like on my truck, what's really cool about the 5.9 common rails is the ECU controls the exhaust brake, and it basically turns the brake off at idle if you're over 180 degrees. So I have mine set to 1 minute, and if I'm idling for so long and my engine gets cold, it kicks the exhaust brake on, it automatically regulates my exhaust pressure to 10 pounds, and then once my engine gets back to 180, it turns it all off again. So that's a function of the 5.9 ECU. Other ECUs might have it, but right now, as far as I know, that's the 5.9 ECU is the only one I'm familiar with. And then you have your gauges. Like I said, you have your command position, which right now I'm commanding it to 0. My feedback is the turbo. Actuator temperature on this one doesn't apply because there's no sensor for it. Actuator load is at 100%, so the solenoid's fully engaged. It's actually getting hot if I put my hand on it because it's commanded to 0. And if I turn this to 0, the controller thinks it takes 100% of the load to get to 0, so it won't drop it. Turbine speed, same thing. There's no turbine speed on this turbo, so it doesn't matter. There might be a few out there that do have it, but the Zuzu and Powerstroke ones that I have don't. Your drive to boost ratio, that's your current ratio. Right now I'm not making any, so it's 0.0. My target's 2.5. Map PSI, exhaust PSI, that's all kind of common sense. Engine speed, same thing. This is your vehicle voltage. I'm running on an AC to DC power supply, which is also why I have engine RPMs there from interference from it. And this is my CPU temperature. So you also have the voltage inputs. So if you're trying to diagnose something, like for some reason you don't feel like you're making pressure, you should have roughly 0.5 here, 0.5 there, and then whatever the value is. So the Banshee kits come with a 150 pound sensor, so at 150 pounds they should read 4.5 or relatively 4.5. You have your exhaust brake trigger voltage that I mentioned earlier, and then you have your feedback sensor for this turbo. If you're not using this turbo, you know, this might be used for something else or not used at all. Just depends. Alright, so now I'm going to go back to my boost drive ratio. I just saved it to 25, so now you're going to see my command position is going to change to 25. I don't have shop air to it, so it's going to say 0, and I'm going to plug this back in, and it's going to get loud with the compressor. Oops. So as you see, I commanded 25 and it's kind of bouncing a little bit, but that's because there's no weight going against that arm, so it's kind of fluctuating. Alright, yeah, that's pretty much it. I was moving the actuator back and forth so you can see it moving here and you can move on the screen. I just killed the compressor. So now I wanted to show you how it works. Put this up, bring it back. Alright. So right now the actuator is being commanded to 50%. Well, not really 50%. It's trying the way it works is I'm commanded to 50%, and then it's increasing and decreasing that load value in an attempt to get to 50%, and then it's going to try to pull it back to use as minimal amount of power as possible. So as you can see, when I move my feedback knob, it's going to change the load. So if I go down towards the brake, it's going to lower the position because the hydraulic pressure is going to force this thing open. And if I overshoot it, the same thing happens. It's going to start coming back. So the actuator is completely off. I'm not putting any power into it. And then the hydraulic pressure would force it open. And if you get to 50, everything's happy. But if you go past it, then the controller is going to try to correct it by increasing the power. But yeah, that's it. It's pretty straightforward. I still have a little tweaking to do on the software. Like I said, the text box, when you click calibrate, that's actually the text box that pops up for the whole set. I kind of just copy and pasted the code, so I have to update that to be more in reference with this. You can use any pressure sensor as long as it's a gauge. Not all sensors are plated equal, so cheaper sensors, they read differently, and it's not going to be as accurate as it should. The sensors I supply are pretty accurate. They're 150-pound Honeywell sensors. Same thing for the exhaust pressure sensor. Engine speed. If I don't have your truck here, like I said earlier, you can just hit user define and program whatever your pulses are. Turbine speed not needed. But yeah, let me know what you guys think. This is pretty cool. I was actually surprised I was able to figure it out in a day. I posted the first video yesterday of me just playing around with the air compressor. But I started on this morning and finished it a few hours ago, so kind of surprised. So the next step is to find a volunteer that wants to run it. So anyone who has basically wants to test it out, get a free controller. The catch is you have to have a running truck with the turbo setup, with the plumbing setup. Everything's running. The only thing you're missing is the controller. If that's the case, then if you're the lucky guy, I'll give you a controller for free, full kit. You can install it. Just take pictures, make a YouTube video. If you think it sucks, say it sucks. If you think it's cool, say it's cool. But if you say it sucks, let me know how I can fix it and make it better. But yeah, like I said, the only catch is you have to have it ready to go, and the only thing you're missing for your project is the controller. And then we can make it work, and you can be the first guy to run this turbo off a 6.0, or if you find a Zuzu or another turbo that's a VA series that you want to use. Yeah, so pretty cool. The Banshee VGT controller is the first standalone universal controller that can now control the Garrett VA series found on the Powerstrokes, Duramaxes, and the Zuzus. Thanks. Bye.